Warm welcome to all of you. Today we will discuss about the introductory details of machine learning. Machine learning enables computers to learn from data rather than simply relying on explicit instructions. So machine learning, it will never rely simply on instructions. It will rely on data. Based on data only, it will take any sort of decision making. A simple example has been given. A spam filter learns from thousands of labeled data whether an email is a spam or not a spam, not instead of manually uh, getting rules from external. It focuses on identifying patterns, relationships, and structures within datasets to make predictions or decisions. So, machine learning majorly it relies on identifying various sorts of patterns and relationships and structures existed in the data to predict what will happen in the future. But the best example, finding that screen time correlates. The next one, machine learning models improve performance over time as more data is provided. So the simple example, this is as data is more and more, the accuracy of the output also will increase more and more. The best example, a language models trained on 1 million sentences achieves 75% accuracy, but with the 10 million sentences, accuracy reaches to 92%. So this tells that the output of the model will increase as the sample size increases. The next one, machine learning is a subset of artificial intelligence concerned specifically with learning based algorithms. The best example, AI include rule based systems and search algorithms. Machine learning specifically uses neural networks, decision trees, and other sort of algorithms. The next one, machine learning provides machine learning problems generally falls in three different categories. As we know very well, machine learning will fall under three different categories: supervised machine learning, unsupervised machine learning, and reinforcement learning. Supervised machine learning for labeled data, unsupervised machine learning for unlabeled data, reinforcement learning, it depends on rewards and punishments. For every positive action will be rewarded, for every negative action will be penalties will be imposed. The next one, supervised learning uses labeled data. So supervised machine learning will have a specific label. The best example, house prices, classification, age, gender, educational qualification, income. So every supervised machine learning data will have a specific label. Training, for example, training a model with the size 1500 square feet, price $3,000. The next one, unsupervised learning finds hidden patterns or grouping without labels. The best example for unsupervised machine learning, clustering, dimensionality reduction, or the unsupervised machine learning. So in unsupervised machine learning, we will not have a specific labels. The best example, grouping customer purchases data into various segments: frequent buyer, occasional buyer, and seasonal buyer. Here, we will not have any specific label. We are trying to group into through different sectors. So the next one, reinforcement learning teaches agents through trial and error basis interacting with an environment. A game AI learns to play chess by winning for rewards and losing for penalties. So basically, reinforcement learning it's depends on trial and error basis, guided by rewards and penalties. For every positive action will be rewarded, and for every negative action, penalties will be imposed. This is the main philosophy of this reinforcement learning. Machine learning models learns by minimizing error or loss using mathematical optimization techniques like gradient boosting algorithms. So ML models accuracy will be increased whenever it tries to minimize the loss in the model. Adjusting model weights are step by step to reduce prediction error, like rolling a ball down a hill to find the bottom. So majorly machine learning algorithms accuracy will be increased whenever we try to minimize the error existed in the model. Training data quality has a crucial impact on accuracy, fairness, and generalization of machine learning models. As we know, the whole data in machine learning will be categorized into two parts: training data and testing data. The accuracy of the model depends on the how effectively we are trying to train our model. A face recognition model trained only on one ethnicity fails to generalize. Clean, diverse data improve accuracy for all groups. Overfitting occurs when a model memorizes training data instead of learning generalizable patterns. So, overfitting occurs. A model performs well on trained data but poor on testing data. So, this is one of the problems. A model achieves 100% accuracy on training data but only 60% accuracy on testing data. This is one of the problem in machine learning. So the problem we call it as overfitting problem. The next one is evaluation metrics. So we have to assess the model accuracy with the help of various parameters like accuracy, precision, recall, uh, root mean square error, and these all are the evaluation metrics. With the help of this, we are trying to assess the accuracy of the model. The best example: accuracy 92%, correct prediction, precision 85% of spam predictions are true. And the next one, feature engineering, selecting or transforming important inputs often determines the success of machine learning projects. The example, converting raw height and weight into body mass index improves prediction accuracy. So, feature engineering will tell us about transforming certain various inputs also into a one form, which will be more benefit for us. So machine learning is widely used in a various sector. The best example, healthcare sector, finance sector, marketing sector, autonomous sector, educational sector, and cyber security, whatnot. Machine learning, it is very frequently used in many areas nowadays. For example, healthcare disease diagnosis from X-rays, finance fraud detection in transaction, autonomous self-driving cars are the various suitable examples that we can able to generate over here. Responsible machine learning involves addressing biases, privacy, interpretability, and ethical concern in model development. So, ensuring a hiring model does not discriminate by gender, protecting user data privacy, data security, and ethical aspects are the most important aspects, especially in responsible machine learning algorithms. So, likewise, we have so many suitable and better advantages, especially in the case of machine learning. The bias variance, the bias variance trade-off balances underfitting and overfitting to achieve strong generalization on new data. To achieve a strong generalization on new data, we have to create a balance between um, between these two things. High bias. So the next one is regularization techniques. There were L1 regularization and L2 regularization, and dropouts controls the model complexity and helps to prevent overfittings. To prevent the overfitting, we have to use certain regularization techniques in machine learning like L1 regularization and L2 regularization. L1 regularization forces some weights to zero feature selection. L2 keeps weights small. And the next one, machine learning systems go beyond training. We must deploy, monitor, and continuously improve model in production environment. Example, after training, models are deployed via application programming interfaces. Performance is monitored with metrics and retained when data distribution changes. So over a period, we have to monitor the performance of a model by continuously observing what exactly is happening. A model, a modern machine learning workflow is iterative in nature, who starts from data collection, building model, evaluate, uh, and learn from feedback. So the first starts with collect label data, train the model, validate and test set, deploy, collect user feedback, retain with new data, or the various steps which will fall under machine learning process. Machine learning is rapidly evolving, enabling more specialized, safer, and more reliable intelligent systems nowadays. The example future ML personalized medicine provided to the customers, autonomous vehicle and smart assistants, and focus on interpretability, fairness, or these are the various aspects of machine learning. Thank you.